Hello everyone. Today we are going to discuss about Legendre'S equation and some results which are very important in for MSc and higher classes mathematics. So let's get started. Legendre'S equation. Legendre'S equation is given in the form 1 minus x square d square y upon dx square minus 2x dy by dx plus n bracket n plus 1 bracket close y equals to 0. And Legendre'S equation, or we can say Legendre function, in terms of pnx and qnx is given by y equals to a pnx plus b qnx. So let's discuss about the generating function of pnx. 1 minus 2xz plus z square whole power minus 1 by 2. This is called the generating function. This is called the generating function of Legendre's polynomial. Now let's see the proof. We will prove it. 1 minus 2xz plus z square whole की power minus 1 by 2. We can write it like this. 1 minus is we have taken common. So bracket 2xz minus z square. Why we are writing minus here? Because we have taken minus outside the bracket. So sign inside the bracket will change. Now what we will get? We will get 1 plus 1 by 2, this term as it is, plus 1 by 2, 3 by 4, again same term, plus say dot 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 dot. So our last term will be 2k minus 1 upon 2. K will come here, 2k will come here, and the same term 2xz minus z square की power k. I hope this is clear to you. Now what we will get in short form, 1 plus summation k to equals to 0 up to infinity 1 by 2, 3 by 4, and last term 2k minus 1 upon 2k and 2xz minus z square की power k. This is our first equation. Now again 2xz minus z square की power k, we will take z. If we take z common, z outside, what we will get? Z की power k, 2zx minus z square is here na, so we have taken z outside, so one z will left inside, and again we will apply the identity. What we will get? 2xk minus k x k minus 1 z, like this. K minus 1, 2 factorial, 2x k minus 2 z square. So our last term will be minus 1 k z की power k. So this is our second and this is our first equation. Using first and second equation, what we will get? We will write the value of 2xz minus z square की power k here. We will put this value here. So what we will get? We will get this 1 minus 1 plus summation k equals to 0 up to infinity 1 by 2, 3 by 4, and this term as it is. I hope this is clear to you. Now what we will do next? Our next step will be coefficients of zn in expression 3. This is our third expression. So we will take the coefficient of x की power n, and like this we will get p of n x. So what we have taken, what we have get? 1 minus 2xz plus z square minus 1 by 2, which we have taken earlier in the beginning. What we will get? Equals to summation n equals to 0 up to infinity pnx zn. I hope this proof is clear to you. Now we will do some corollary. Our first corollary is pn1 equals to 1. We will prove this. So it is very simple. Let's start. 1 minus 2xz plus z square की power 1 by 2 can be written as like this. We are using it here for proving this corollary. summation n equals to 0 to infinity pn zn की power x की power n. Okay, now let us put x equals to 1. We will put x equals to 1 in this. So in place of x we are writing 1. It can be written as 1 minus z की power 1. Why? Because this is the identity a minus b whole square. So we can write it like this, 1 minus z का whole square. So 2 and 2 will cancel, but we will get 1 minus z की power minus 1. And this term we will write like this. Now what we will do, 1 plus z square up to zn is equals to this. Now we are comparing the coefficients. Now we are comparing it. We can write it like this. Comparing the coefficients of zn, what we will get? P of n is equals to 1. See, zn both sides are given. Summation n equals to 0 to infinity are also both sides. So what we will get? P of n power 1 equals to 1. I hope this is clear to you. First one is clear to you. Now second corollary. Now again we will use this. This time in place of x we will put x is equals to minus 1. In first corollary we put x equals to plus 1. In second corollary we will put x equals to minus 1. Putting x equals to minus 1 both sides. So this term will become positive. See. Same step. Now this time we are applying identity a plus b whole square. So we can write it like this, 1 plus z का whole square multiplication minus 1 upon 2. So 2 and 2 will cancel, minus 1 will left. Again same step we are doing. Now comparing the coefficients of zn, what we will get? P of n1 equals to minus 1. I hope this is clear to you. Now let's see one example. Example, P of n minus x equals to minus 1 and Pn x. Again we will use the same thing, 1 minus 2xz plus z square minus 1 by 2 equals to summation n equals to 0 to infinity Pn x zn. Now in this we will replace x by minus x. So in place of x we will write minus x. What we will get? 1 plus, in place of x we are writing minus x, 1 plus 2xz plus z square minus 1 upon 2 equals to summation n equals to 0 to infinity Pn in place of x we are writing minus x zn, and z is replaced by minus z. This is our second equation. And in the main equation, in first we are replacing z equals to minus z. So in place of z we will write minus z. See, I hope this is clear. Now this is our third equation, this is our second equation. Comparing second and third equation, what we will get? Left hand side is same, left hand sides are equal, same. We will compare, we will write the right hand side. We will compare the right hand side. Now Pn minus x is equals to minus 1 की power n Pn x. I hope this is clear to you. Now next, recurrence relation of Legendre'S function Pn x. We will do some recurrence relations. We will do some results which are very important in special functions. So let's start. N plus 1 P of n 1 plus 1 equals to 2n plus 1 x Pn x minus n P n minus 1 x. Again we will use the same generating function as we are using in earlier questions. 1 minus 2 xz plus z square minus 1 upon 2 equals to summation n equals to 0 to infinity z की power n Pn x. Now in this we will differentiate it with respect to z. We will differentiate it with respect to z. So what we will get? Minus 1 by 2, this term as it is, and with respect to z we are differentiating it. So minus 1 by 2 will come here, this term as it is, and power will be minus 3 by 2 and minus 2x plus 2z. I hope this step is clear. It is very simple, only 12th class concept we are using. Here summation n equals to 0 to infinity n z n minus 1 p n x. We are taking 2 common from this bracket. 2 will come outside, and this 2 and 2 which we are taking outside will cancel. What will left? And it is negative term. So what will be in the bracket? Z minus x minus z, and this term same as it is. Minus 3 by 2 can be written as minus 1 by 2 minus 1, and this term same as it is. So minus 1 minus 2xz plus z square will go this side because it is negative term. Minus 1 we can write it like this, it will become positive. I hope this is clear. It is very simple concept. Okay, now 1 minus z, and as we know it is our generating function, so in place of this we can write summation n equals to 0 to infinity z and p n x equals to this term as it is, and this same. Now we are comparing the coefficients of zn. If we are comparing the coefficients of zn, what we will get? We will get this, and we have to prove this. It was the first recurrence formula, recurrence relation. It was our first recurrence relation. How we are getting? We are getting the by comparing the coefficients of zn. If in this we will get this, and we have to prove this in first. This was our first recurrence relation. Now let us start our second recurrence relation. Our second recurrence relation is Pnx equals to P dash n plus 1x equals to minus 2x P dash n x plus P dash n minus 1x. So how we will prove it? It is very simple. Let's start. We are differentiating it. We are differentiating first with respect to x, as we have done in first C. Differentiating first with respect to x. What we will get? Minus 1 upon 2. Same step. Same step we are doing. See, this was our generating function. We are differentiating it with respect to x. In first recurrence relation, we have differentiated it with respect to z, and in this we are differentiating it with respect to x. Now differentiating it with respect to z, 2 will come outside, 2 and 2 will cancel. This term is negative, this term is also negative, it will become positive, and it can be written as minus 1 upon 2. Same step, minus 1 will, this 1 minus 2 zx plus z square is minus 1 will go this side, it will become positive, and this step as it is. Now this is our recurrence relation. It can be written as summation n equals to 0 to infinity z and p n x is equals to same step. I hope this is very clear because we have same type of recurrence relation. We are proving it in the same way, only the difference is in first recurrence relation we are differentiating with respect to z, and in this we are differentiating with respect to x. Only this is the difference, otherwise it is same, both are same. Now in this step what we will do? We will equating the coefficient of zn plus 1. We will equate the coefficient of zn plus 1, and we will get our second recurrence relation which we want to prove. I hope this is clear. Now third recurrence relation, differentiating recurrence relation 1 with respect to x. Now what was our recurrence relation 1? This is our first recurrence relation. We are differentiating it with respect to x. See, we are differentiating it with respect to x. And from second recurrence relation, this was our second recurrence relation, we can write like this, using 3 in 2. 3 in 2 means this is our third recurrence relation and this is our second recurrence. Second step, third step. So in place of p dash n plus 1, we are writing it. So what we will get? N plus 1 as it is. P dash n plus 1, in place of p dash n plus 1, we are writing this. See, otherwise the same steps are same. So what we will get? We will get our third recurrence relation. After solving it, after cutting, cancelling, we will get our third recurrence relation. Now, fourth recurrence relation, n plus 1 p n x equals to p dash n plus 1 x minus x p dash n x. Adding recurrence 2 and 3. Adding, this is our third recurrence and this is our second recurrence. Adding these two recurrences, we will get our fourth recurrence. Now fifth recurrence, this is our fifth recurrence formula. Adding 3 and 4, we will add third and fourth recurrence, we will get our fifth recurrence. Now sixth recurrence, this is our sixth recurrence formula. Now replacing n by n minus 1 in recurrence 4. See, we are replacing n, in place of n we are writing n minus 1. So n plus 1 will be n and n will be n minus 1 equals to p dash n plus 1 will be n minus x p dash n minus 1. I hope this step is clear. Just we have just replaced n by n minus 1. It means in place of n we are writing n minus 1. And multiplying by x. Multiplying the recurrence relation third by x. थर्ड रिकरेंस रिलेशन को हमने किससे मल्टीप्लाई कर दिया? x से. सो ये रहा हमारा थर्ड रिकरेंस रिलेशन, हमने इसको x से मल्टीप्लाई कर दिया है. ओके, मल्टीप्लाई रिकरेंस रिलेशन थर्ड बाय x. सो you will get this. Subtracting these two, subtracting 5, step 5 and step 4, we will get our sixth recurrence relation. Now seventh and the last one, seventh recurrence relation, 1 minus x square p dash n x equals to n plus 1 x p n x minus p n plus 1 x. Now replacing n by n plus 1 in recurrence relation third. Where is our third? This was our third recurrence relation. We are replacing n by n plus 1, means in place of n we will write n plus 1 and solve. We will get this step. Multiplying recurrence 4. This is our fourth recurrence relation. We are multiplying it by x and then subtracting. Sixth step and seventh step. Subtracting 6 from 7 and we will get our seventh recurrence relation. I hope these recurrence relations, these 7 relations are clear to you. Now only one example, last example, then we will close. Prove that, this is very simple. Prove that integration pnx dx plus c equals to pn plus 1x minus pn minus 1x upon n plus 2n plus 1. See, according to recurrence relation 5, this is our fifth recurrence relation. 2n plus 1 will go this side and it will become in denominator. We will get this step, very simple step, integrating both sides. We are integrating both sides, we will get this step. Bas, that's it. We have to prove it. I hope this is clear. This is for today. I hope you liked the video. Thank you so much. For more videos and for more higher class in mathematics, you can visit my more YouTube videos. Thank you so much.